stoichiometry problems is an extremely useful skill and can be very simple.
To introduce this concept, we'll do a basic example problem and narrate along with steps.
The first step is always to read the problem thoroughly and identify what the known and unknown substance is. If the problem is given in a word form, you should translate it into a chemical equation.
In this problem, we will address a stoichiometry problem that uses grams. The problem reads as follows. If 10 grams of Al is reacted with enough oxygen gas, how many grams of Al2O3 are produced? In this problem, 10 grams of Al is our known, and the amount of grams of Al2O3 is our unknown. This problem is in word form, but it translates to the following chemical equation. Al plus O2 produces Al2O3. In this problem, the balanced form of Al plus O2 produces Al2O3 is really 4Al plus 3O2 produces 2Al2O3. If at this point in the video you are confused as to how to balance a chemical equation, stop this tutorial and refer back to one of our previous YouTube videos.
Once you have a balanced chemical equation, step number 3 is to convert the units of the known substance to moles.
In this problem, that means we must convert our known 10 grams of Al to the equivalent amount of moles of Al. So we multiply 10 grams of Al times 1 mole of Al over the molar mass of Al, which can be found on the periodic table, which produces 0.37 moles of Al. We multiplied 0.37 moles of Al times the leading coefficient of Al2O3 and Al, which could be found in the original equation. This gave us 0.19 moles of Al2O3.
Lastly, convert the substance in moles you found to the unit of measurement the problem calls.
Because we started with grams, we need to convert the mole value back to grams. So here we multiplied our mole value, 0.19 moles of Al2O3, times the molar mass of 2 Als plus 3 Os to give us 18.9 grams of Al2O3, which gives us the value of Al2O3 back in its original gram form.
Now you have successfully completed a simple stoichiometry problem. We're now going to see how stoichiometry can be used by farms. Not only is stoichiometry used in chemistry, but it could be also used and seen in real-life examples.
Let's start with a real-life example, such as farming. A farmer needs to know when to grow his crops, how to fertilize, and how much fertilizer to use, as well as when to harvest, and how to sell the crop to make income.
To sell the greatest amount of a certain crop, farmers often use fertilizer to make them grow faster and more ripe/healthy. With this, fertilizer costs lots of money, and stoichiometry could be used to find how many bags you'd need and how much it would cost.
For example, corn eats up lots of phosphorus from the soil, so in order to keep the soil stable and strong, fertilizer, which contains phosphorus, is added to the soil. Let's say that a farmer has a farm that consists of 150 acres.
An acre of corn will remove 5 kilograms of phosphorus from the ground. The fertilizer the farmer will buy is superphosphate with the molecular formula of Ca3P2H14S2O21. A normal bag of fertilizer costs $48.73.
This is where stoichiometry would come into place in a real-life farming example. First, the given is that one bag of fertilizer weighs 11,000 grams, and 454 grams equals 1 pound. With this, let's figure out how much fertilizer a farmer would need. The conversion factor is 1 acre of corn equals 5 kilograms of phosphorus. With this, let's figure out how much fertilizer a farmer would need. The conversion factor is 1 acre of corn equals 5 kilograms of phosphorus. So to find how many grams of phosphorus a farmer would need for 150 acres of land, you multiply 150 acres of land times the conversion factor 5 kilograms of phosphorus over 1 acre, and then multiply that by 1,000 grams of phosphorus over 1 kilogram of phosphorus to convert kilograms to grams. We end up with a total of 750,000 grams of phosphorus.
Next, the farmer would need to find the molar mass of Ca3P2H14S2O21. Molar mass is 596 grams. To find the percent of phosphorus, you would have 62 grams of phosphorus inside of the molecular formula, and then you would just divide it by 596 grams times 100 to get 10.4% of phosphorus.
Since the fertilizer weighs 11,000 grams, which is close to 24 pounds, we can determine how many bags of fertilizer we would need to be used. 10.4% of 11,000 grams produces 1,144 bags. Now we take the 7.5 times 10 to the 5th and do this equation to find the amount of bags. So 7.5 times 10 to the 5th over 1,144 grams / bags. Doing this problem gives us 666 bags of fertilizer.
In order to find the price of the bags, you would multiply 666 bags times the original price, which is $48.73. The amount of bags you would need is 666, and the total cost would be $32,454.
So instead of asking yourself, why is this important and why do I have to learn this, just know that stoichiometry problems in real life are a part of reality and could most definitely relate to something you do every day. Thank you so much for listening on our stoichiometry lessons. Bye!